To find out necessary and sufficient condition for ax square plus 2hxy plus by square is equal to 0 and a dash x square plus 2h dash xy plus b dash y square is equal to 0 have at least one line in common. Right? And it is same equation. So what we should do is one line in common. We should solve these two equations as simultaneous equations in x square and x. Solve as simultaneous equations in x square and x. These are the two variables that we have and we know how they are related to each other. Therefore, if I want to solve simultaneously, I will write it like this: x square plus 2hy times x is equal to minus by square a dash x square plus 2h dash y x is equal to minus b dash y square. And therefore, x square is equal to by square into 2h dash y what should we do? Should we use it? Okay, let me put slope form because x and y will trouble us otherwise. Let me put it in slope is let slope of one of the lines is m and they are passing through origin, therefore y by x is our slope. So the first quadratic equation becomes a plus 2hm plus bm square is equal to 0 and second quadratic equation becomes a dash x, so a dash plus 2h dash m plus b dash m square is equal to 0. And now let me solve these two simultaneously to eliminate m because this is the slope. Slope of the line which is common to both will be satisfying these two equations. And now let me solve it. Bm square plus 2hm is equal to minus a b dash m square plus 2h dash m is equal to minus a dash. Therefore, m square is equal to minus a minus 2a h dash plus 2a dash h upon 2bh dash minus 2b dash h, and m is equal to minus a dash b plus ab dash divided by 2b h dash minus 2b dash h. Okay, so these are the values. Once we solve these two quadratic, they are simultaneous equation in m square and m. Therefore, we get the necessary and sufficient condition as 2a dash h minus the 2 we can cancel. Na? Okay. 2 we can cancel and we get a dash h minus a h dash upon bh dash minus b dash h. This is your m square, which is equal to minus a dash b plus a b dash upon 2bh dash minus 2b dash h square, right? So that makes it, this is what I mean, we have got the relationship between all the coefficients, and now we should write it. I mean, if I square this, I will get denominator cancelled because it is one and the same, except that 2 is present here. So 4 times a dash h minus a h dash square is equal to 9. काय करायला पाहिजे? बरोबर चालतंय?
सर स्क्वेअर नाही येणार.
काय करतोय मी, मला काय समजत नाही आहे. एक मिनिट. हा डिनॉमिनेटर दोघांचे जर सेम केले 4 टाइम्स झाला. हा एक डिनॉमिनेटर कॅन्सल होईल. सो 4 इंटू एच डॅश इंटू बी एच डॅश मायनस बी डॅश एच इज इक्वल टू ए बी डॅश मायनस ए डॅश बी ब्रॅकेट स्क्वेअर. बरोबर आहे? Is this correct now? Yes, it seems it is correct. Therefore, we can write it in the form b 2h b dash 2h dash into 2h a 2h dash a dash is equal to b a b dash a dash bracket. I mean, this is the necessary and sufficient condition. Let me know if you have any doubt.
Sir, how did we get that m square?
Okay. Another brute force method for finding out the necessary and sufficient condition for one line to be common in both of them is actually you factorize both the equations. So small L1 is a factorization of first equation and L2 is second. Capital L1 and capital L2 are the factorizations of second homogeneous equation. So we assume small L1 is equal to capital L1. Coefficients must be proportional. So we start from here. A upon a dash is equal to h plus radical h square minus ab upon h dash plus radical h square dash square minus a dash b dash. And if you keep simplifying, you will eventually, after simplification, get exactly the same condition, which we got by simultaneously solving the slope equation. One can go through these calculations, and because we are getting the same condition, end of the day, all calculations are correct. Okay, the last thing in POL that we need to do is, let me give you a problem, question. You try to solve that question, then we will try to figure out the better method of solving that question. Find joint equation of POL. Passing through origin. And the point of intersection. The line 3x plus 4y minus 5 is equal to 0 and 2x square plus 3y square is equal to 5. You don't know what this conic is, but this line intersects this conic, those 2 points, say A and B. What is the joint equation of POL passing through A and B and origin? That is the question. Okay, so the conventional method or the standard method by which you will try is to first find out coefficients or coordinates of A and B by solving these two equations simultaneously, and which is going to be difficult because the numbers are not going to be good. This is some conic section. 2x square plus 3y square is equal to 5, and this is some line 3x plus 4y minus 5 is equal to, and there is some origin somewhere, and you are interested in finding out joint equation of straight lines passing through points of intersection and origin. You want joint equation of this POL, right? And the innovative method of doing it is called homogenization. Because we know that the lines passing through origin, joint equation of POL is a homogeneous equation in x and y. Always we would homogenize these two. How? Look at this. 3x plus 4y is equal to 5. Therefore, 3x plus 4y upon 5 is equal to 1. So let us use this one in innovative way. 2x square plus 3y square minus 5, this is minus 5 LHS, into 1. And what is our 1? 3x plus 4y upon 5 bracket square is equal to 0. What have we achieved here? This bracket is 1 and its square is 1. Therefore, we have not changed the equation at all. It is one and the same equation. However, this equation, if you look at it, it is homogeneous in x and y. Let us find out what this equation is. First of all, out of these two 5s, you can get rid of one 5 from here and put only one 5 here. Multiply everything by 5, we get 10x square plus 15y square minus 9x square minus 16y square plus 24xy is equal to 0. And now if you observe, this is what? X square minus y square plus 24xy is equal to 0. Is this equation homogeneous in x and y? Yes. So it must pass through origin, correct? Suppose this point is A, coordinates xa, ya. Is this point on the conic? Yes. Therefore, it will satisfy conic equation. This was conic equation. It will satisfy. Is that point on this straight line? Yes. Therefore, it will satisfy this also, and hence it will satisfy this equation. Point B also will satisfy this equation. And if you have 3 points, then 3 points you will end up having 3 POLs passing through 3 distinct points if they are not collinear, out of which we want the one which passes through origin. This is the one. Homogenizing using one very effectively. Okay, solve second one. Suppose conic section is x square plus 2y square plus 3x minus y plus 2 is equal to 0, and the line is x minus y is equal to 2. Find joint equation of POL passing through intersection and origin. There is a correction in the upper statements. Instead of plus 24xy, minus 24x. Now here, what is your 1? 1 is x minus y upon 2 is your 1. And therefore, homogeneous equation will be x square plus 2y square plus 3x into x minus y upon 2. Only once. Minus y into x minus y upon 2. Only once. Plus 2 into x minus y upon 2 bracket square is equal to 0. Now this is a homogeneous equation in x and y passing through point of intersection of those two geometries and passing through origin. So after simplification, you will get the answer as x square plus y square minus xy is equal to 0. Okay. Question. Find the value of m. If the lines joining origin and point of intersection A and B of y is equal to 1 plus mx and x square plus y square is equal to 1 are perpendicular. एक मिनट joining the origin. हाँ एक मिनट origin मांगा था कि ना lines joining the origin and the points of intersection A and B of this line and this circle are perpendicular. Simple. For the records, the problem is to be solved. Now it is again homogenization and you get your 1. 1 is equal to y minus mx is equal to 1. Right? So x square plus y square minus 1 into y minus mx bracket square is equal to 0. So when you expand this and collect proper terms, we get 1 minus m square into x square plus 2mxy is equal to 0. And now these two lines, this is POL and they should be perpendicular to each other. Therefore, condition for POL to be perpendicular, a plus b is equal to 0. Coefficient of x square and coefficient of y square should add up to 0. But here coefficient of y square is anyway 0. Therefore, 1 minus m square must be equal to 0. And hence, m is equal to plus or minus 1. Will give you perpendicular lines passing through origin. Next question. Find the joint equation of POL. Find the color change. Question. Find joint equation of pair of tangents. To circle x square plus y square minus 2x plus 4y minus 4 is equal to 0 from minus 2 comma 3. Also find angle between the lines. and tan of angle between the lines. So, okay. Now, you have to look at the theory properly. Now, few lectures before, when we said we have a conic, conic is not behaving well these days. Conic, no. Conic section. I have to complete it. Ah. Then I have point P, and we said variable line intersects at A and B, and there is a point Q. Then PA upon AQ and PB upon BQ can be two distinct ratios. We said let it be, let this point was x1 y1 and this point was x2 y2, and we said let PA upon PB AQ is equal to K, and if then we started finding out coordinate of A, which was K x2 plus x1 upon k plus 1 comma ky2 plus y1 upon k plus 1, right? And then we put this back into our general equation, ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0, right? So we did this and then simplified, and we got a very good relationship. JR equation. We got JR equation, and if we simplify it, and simplify it, eventually shortest equation that we had was k square s plus 2kt plus s1 is equal to 0. What is s? The general conic. This is the conic s. K square times this, okay, it was s2. K square s2 plus 2 times kt plus s1. Now, finally what we did was replacing x2 by x and y2 by y, we get desired locus of q, and we were interested in repeat root of this quadratic. No, not repeat root. What we were interested in is sum of the roots to be 0, because PA upon AB we wanted it to be numerically equal to PB upon BQ, but opposite sign. Therefore, we equated T is equal to 0. Okay, but then what is this S2? S2 was your x2, but if we are looking for locus of q, then we should have called it as x dash y dash, and replacing x dash by x and y dash by y, we get desired locus. That is what eventually we will say, and hence we are interested in q, and hence we remove this and say that it is s after replacing by x comma y. Okay, so now if we have this Joachim-Thals ratio equation, JR equation, what do you think will happen if this variable line is tangent to this conic? What will happen if this variable line is tangent to this conic and it is tangent to this conic at the other side also? So here A, Q and B, all of the three will coincide. Is that right? This side as well as this side. That means the ratio, K ratio is going to be repeated. So K quadratic should have a repeat root. What is, we have used only sum of the roots condition of this K quadratic. Now it is time to use another condition. What geometry can we imagine if this K quadratic has repeat root? That means this variable line is tangent, maybe at 2 points. Yes, one here, one here. A comma B comma Q are going to be coincident. I mean, Q you can have Q anywhere. So I mean, Q, if it is a harmonic conjugate, then it will coincide. But otherwise, you can take Q anywhere. PA upon AQ is equal to PQ, PB upon BQ, right? And at that time, this K is going to be repeated. Is this fine? Suppose I take Q here, then first ratio is PA upon AQ. Will it be numerically exactly equal to PB upon BQ? Yes, because A and B are coincident. Here, if that line is somewhere else, A and B are distinct. Therefore, K values can be different. In this case, K values are going to be same. And therefore, what we get out of this quadratic equation, if the roots are same, delta must be equal to 0. What is the delta of this quadratic equation? It is 4t square is equal to 4s1. That is, t square is equal to ss1. So t square is equal to ss1 is the condition when you will have your variable line tangent. Now, if you look at the degree of t square is equal to ss1, it is degree 2 equation in x and y. Therefore, this is going to be joint equation of tangent. That is, how will it look like? You put value t. T means axx1 plus byy1 plus h into xy1 plus yx1 plus g into x plus x1 plus f into y plus y1 plus c bracket square is equal to s is same, ax square plus by square plus 2hxy plus 2gx plus 2fy plus c, that is your s, and s1 is ax1 square plus by1 square plus 2hx1y1 plus 2gx1 plus 2fy1 plus c. This is your joint equation of the tangents. So in given problem, if we use this, let us see what answer we get. And already Sudhanshu has got the answer from some other way, and we can tally that. So minus 2 comma 3 is to be put. So minus 2x plus 3y, then xy term is not there, so minus 1 into x minus 2 plus 2 into y plus 3 minus 4. This is your t square is equal to s, which is x square plus y square minus 2x plus 4y minus 4 into this is going to be a numerical number. So 4 plus 9 plus 4 into 12. Okay, let us simplify this. This is minus 2 minus 1 minus 3x. 3 plus 2 is equal to 5y, and constant plus 2 plus 6 plus 8 minus 4 plus 4 square is equal to x square plus y square minus 2x plus 4y minus 4 into 12 आणि 8 20 29 वजा 4 25. simplify this and you will get final answer is x plus 15xy minus 13x plus 30y minus 58 is equal to 0. 9x square minus x square, that is 8x square. What is xy term? Oh, it is minus 15 minus 30 here. 9, 8x square. I don't know whether it is correct. Check whether this is equal to this. JR equation is a long method of getting the tangent, joint equation of tangent, but it is very useful. T square is equal to SS1. Now let us discuss general theory of conics. Question 56%, 50%. Question. Suppose how many points in the plane minimum you require to fix a straight line? How many points to fix straight line? Easy. You require how many points? 2 points. 1 here, and you fix there will be unique straight line passing through that. 2 points. Why? Why do you require 2 points to fix the straight line? Because it is easy questions. It is very easy question. If we get only 1 point, there are infinitely many straight lines which can pass through a given point. If you give 1 more, then the straight line is fixed. Something like this. Okay. How many points to fix the circle? Question 1.
3.
Question 2. How many points do you require to fix the circle? 3 points. Why? Because, sir, infinitely many circles can pass through 2 points. And if the third point is not collinear with these 2 points, then we can get the third circle geometrically. That is your geometric explanation. But let me try to give you some algebraic explanation. Can you give me algebraic explanation for why do you require 2 points to fix a straight line? Can you give me some algebraic explanation? Yes, easy. If we assume that straight line looks like this, ax plus by plus c is equal to 0. I mean, we have found out that straight line looks like this. Then for fixing straight line, I can convert this there are 3 unknowns. For getting the equation of straight line, there are 3 unknowns. But this is luxury. I mean, you did not have to have 3 unknowns. Even if you have 2 unknowns, it is fine. So I can convert this 3 unknown equation into x plus b by a, provided a is not 0, y plus c by a is equal to 0. So now there are only 2 unknowns, 1 and 2. Okay, and if I give you 2 points, say 1, 3 and minus 2, 5, then I'll get 2 simultaneous equations, and if I solve them, I'll get values of b by a and c by a, and the line is fixed. Therefore, algebraically, there are 2 unknowns and I require 2 points. Therefore, I require 2 points. Do you agree with this? To fix a straight line, we have two unknowns in the equation of straight line, and therefore we require at least 2 points. If we give only 1 point, then there are infinitely many lines, because you take any value of one unknown, you can find out the value of other unknown, therefore infinitely. Similarly, in case of circle also you can visualize that, because their x square and y square coefficients are same. X square plus y square plus 2gx plus 2fy plus c is equal to 0. And there are three unknowns. To fix a circle, you require 3. We cannot reduce it further because we have already fixed these coefficients, 1 and 1. Therefore, three unknowns. Therefore, you require 3. This is better explanation, because if we know the algebraic form of the conic, if we know the algebra of the section that we are discussing, then it is easy to find out how many minimum number of points are required to fix a conic. And hence, now my next third question will be, how many points do you require? Question 3. How many points do you require to fix conic section? Now, when I say conic section, I have this equation in my mind: ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. Right? How many unknowns are there? 6. 1, 2, 3, 4, 5, 6. So, do you require 6 points to fix the conic? How many points will you require to fix a conic? Okay, so there are 5 unknowns, and hence 5 points are required to fix a conic section. Correct? Now, let me give you one conic section. It is a degree 2 equation like this. And a conic section, when intersected by another conic section, this is yet another degree 2 equation. How many points of intersection, real, coincident or imaginary, we expect? How many points of intersection, real, coincident or imaginary, we will expect? Maximum number of points of intersection. 4, right? Because degree 2, when solved simultaneously with degree 2, you will end up getting degree 4 equation in one unknown. And we have already got the theorem in place: nth degree polynomial will have at most n roots. Therefore, there will be, when you solve S1 and S2, two simultaneous degree 2 equations in x and y, 4 points of intersection. Correct? So, if I expect another conic to pass through these 4 points, A1, A2, A3, A4, then I can say there are infinitely many conic sections which will pass through these 4 points. Why? Because for fixing conic section, you require 5 points. Correct? So, if I give you find the equation of conic section which passes through A1, A2, A3, A4 and A5. Oh, then it is unique, it will be fixed. And we don't know what it will be. It could be parabola, ellipse, hyperbola, POL, maybe coincident straight line or a point, whatever. Ray, do you understand this? Next. Therefore, we take the simplest possible cases and start developing our theory. First case, you have a conic section whose equation is S is equal to 0. I have a straight line whose equation is U is equal to 0, and I have another straight line whose equation is V is equal to 0. I want to write down equation of all conic sections passing through points of intersection of these two conic sections. Now, first conic section is S is equal to 0. Anyway, it has got equation degree 2 in 2 variables. Second conic section that I have is u into v is equal to 0. I am taking it as a pair of lines. U is one straight line, v is another straight line. So u into v is another pair of lines, which is a conic section, which is degree 2 in two variables, and they are intersecting each other. Therefore, if I want the family of all conics which pass through A1, A2, A3, A4, can we give it? Can we write down the equation of all conics passing through A1, A2, A3, A4? Okay, so it is simple. It is a family of conics passing through points of intersection. S is equal to lambda u into v. Degree 2, degree 2. Lambda is a parameter which will control everything. And for fixing lambda, suppose I want a conic section passing through this A5 and also passing through A1, A2, A3, A4. Then there will be a unique value of lambda which will be available by putting this point A5 in this equation, and we will get the desired conic section. Very good. That is our diagram number 1. Diagram number 2. Diagram number 2 is, suppose we get one conic and line u, this is s is equal to 0, u is equal to 0, and line v passes through it like this. Then what can you say about the new conic that you are trying to find out? Now equation should not change. S is equal to lambda uv. What can you say about the new conic that you are aiming for? S is equal to lambda uv. Is there any speciality of this conic in case 2? Because you were expecting 4 distinct points of intersection. However, A2 and A3 same. Therefore, all the conic sections that you will get are going to be passing through A1, passing through A4, and are going to be tangent to the given S at A2 and A3. That is what will happen because of obvious reasons. A2 coincides A3. Because of obvious reasons, A2 coincides. New conic will be tangent at A2 oblique A3. Double root A2 and A3 is a double root. Situation number 3. Situation number 3 is you have a conic, you have line U, you have A1, you have A2, S is equal to 0, U is equal to 0. And now I take this A4 also to A1. And therefore this is A3 and this is A4. Yes, what can you say about this? This is V is equal to 0. U and V are coincident. What is the new geometry that you are expecting? The conic section S is equal to lambda uv that you have written. What is going to be the new conic section in this case? The geometry of this new conic section, equation is S is equal to lambda u into u, which is lambda u square. And the geometry will be, it will be tangent here and it will be tangent here. That way you will have another conic, whatever it is. It will be tangent both of places. You may now end up having tangent as this and tangent at this. It can be a POL. something like this. Okay, so that is the third limiting case that we are studying. U and V coincident. The new conic S is equal to lambda U square is going to be tangent. Now let me draw the fourth condition. Fourth condition is you have a conic S is equal to 0. You have a straight line U is equal to 0. And you have another straight line V is equal to 0. Distinct but tangent. So this is A1, this is A2, and this is A3, A4. This is little different than 2. Here the line itself is a tangent, coincident. So S is equal to lambda uv is going to be the equation of new conic. However, in this case, what will happen is new conic will be tangent to old conic at A3 and A4, and also it will be tangent to line V. बघा समजते का? Okay. This is our fourth condition. Our fifth condition. Fifth condition is there is a conic section and there is a tangent U. There is a tangent U and there is a tangent V. A1, A2, A3. Now it is easy. Equation of new conic section S is equal to lambda uv. Okay. The new conic section is going to be tangent to original conic section. It will be also tangent to U and also tangent to V. Simple. Sixth condition. Condition number 6. You have a conic section and you have U is equal, V is equal to 0 and S is equal to 0. Aha. S is equal to lambda U square again. Equation of new conic is same. However, I should have drawn one more diagram before this, but anyway, what is the geometric implication of this? The new conic section will tangent to old conic section and tangent to these both lines. And how many roots are there here? There are 4 points, one above the other, like double root, 4 roots at this point of contact. At this point of contact, you have 4 roots, one above the other. And I should have drawn one diagram before this, maybe 5.5. I have a tangent and a straight line like this. So U is equal to 0, V is equal to 0, and S is equal to 0. Let me call this at 6 and maybe this at 7. In this, your S is equal to lambda uv. The new conic section will be tangent to U, will be tangent to S, and there will be 3 coincident points. It should pass through this. A4. Every new conic section that you are discussing should have 3 roots coincident at A1, A2, A3, and it should pass through A4. And for fixing value of lambda, you need fifth condition. 7, both the lines are coincident. Now, but none of these cases cover the case that we used to discuss. 8. There is a circle and there is a straight line. U is equal to 0. S is equal to 0. And we used to find all circles passing through A, comma B. But then this is different than what we have been studying. Actually, it is not different. Why is it not different? It's because This is also S is equal to lambda U into V. This is your U. And where is your V? Your V, equation of V is equal to 1 0x plus 0y plus 1 is equal to 0. This is the equation of your V, which is the line at infinity. Line at infinity. And of course, that line of at infinity will have two imaginary points of intersection with S. And there are two real intersections with this. And therefore, if you happen to draw a new circle here by using some value of lambda, it will also have the second line V is equal to 0, which is at infinity. And this, so it is the same configuration. This is part of this configuration. And that is why we had to believe that there exists a line looking like this, 0x plus 0y plus 1 is equal to 0, which is line at infinity, and it does that job. And therefore, our S is equal to lambda U into 1, which is our equation S minus lambda U is equal to 0, or we used to call it as S plus lambda L is equal to 0. That is what is our, this is equation of circles passing through all of them. But now we are better and we are saying that equation of all conics passing through those points, etc. So I stop record and ask you to digest this. Now let us take a specific situation where you have a conic section. 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 Last chance. You have a conic section. Still it is not. Anyway. And you have a chord. This is S is equal to 0. Let me write down. S ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. This is S. This is u is equal to 0. Okay. Now let me name these points, maybe P and R. And basically now I am looking at this u and v. Therefore there are 2 points of intersection here and 2 points of intersection here. Therefore the new conic that I will develop through P, maybe PQ and RS is always going to be tangent to S at PQ and RS. Okay, so 4 conditions out of, we require total 5 conditions for fixing the conic, out of which we have 4 points with us, which are PQ, P oblique Q, R oblique S. Okay, and therefore, now if I give you one more point, which I want it to be point of intersection of, is this a new conic section? This is POL and it is a conic section. It is degree 2 equation in X and Y. I am expecting that this POL should be tangent to the original conic section at P oblique Q at one point and R oblique at S at another point. So there will be unique POL which will be tangent to P, tangent to S at P and R, and it will be fixed. Uniqueness of that will be fixed the moment I give you point A x1 comma y1. Right? So equation, how will we write the equation? S is equal to lambda u square. Correct? And therefore, the moment we put point x1 y1 in this equation, we will get value of lambda. So if I put if I put point A in S, we know we get S1, that is AX1 square plus BY1 square, etc. is equal to, and what is U? As far as S is concerned, what is going to be U? U is a coordinate of contact with respect to required POL, which is supposed to be tangent. We will call this U as coordinate of contact. So we know U, I know U, we know U. Okay, so lambda into T square. Therefore, lambda is equal to S1 upon T. Yes or no? Lambda is equal to, नहीं, बरोबर चल रहा है, S1 upon T square.
Sir,
मतलब
why do we need the fifth point?
Wait. हाँ था नीड बघा. For finding out lambda, or let me write down this equation: ax square plus by square plus 2hxy plus 2gx plus 2fy plus c, that is our s, is equal to lambda times, and what is our t? T is ax x1 plus by y1 plus h into x y1 plus y x1 plus g into x plus x1 plus f into y plus y1 plus c bracket square. This is what is happening. Now we are interested in finding out value of lambda. Therefore, what should we do? We should put the conic section must pass through x1 comma y1. Therefore, we must put x is equal to x1 and y is equal to y1. Therefore, what we will get here is ax1 square plus by1 square plus 2hx1 y1 plus 2gx1 plus 2fy1 plus c is equal to lambda times, practically you will get exactly the same except bracket square, and therefore lambda is equal to 1 upon this bracket, which we can call S1. Lambda is equal to this bracket is S1. Okay, and hence if we go back and write down our equation of joint equation of tangent, therefore joint equation of tangents is equal to S is equal to lambda is 1 upon S1 T square, which is T square is equal to SS1. That is what we have proved by one more method. Just geometric interpretation of intersection of two conics and limiting cases. One POL, another actual conic, limiting cases, and now what we expect back is POL passing through a point, specific point given to you, and is tangent at S. So using the 8 diagrams theory that we have developed, very quickly we can get the solution. T square is equal to SS1, that is joint equation of tangent to a given conic passing through a given point. Okay. The case of this 8 is, suppose you have been given a circle and both your lines U are at infinity and they are coincident. That means 0x plus 0y plus 1 is equal to 0 is one line, and 0x plus 0y plus 1 is another line. Therefore, what will be our equation in that case? S is your given circle now, because circle is given, is equal to lambda into 1 square. So S is equal to lambda is your family of new circles, which will pass through the points of intersection of line at infinity coincident two times and a given circle S. Then what is this equation? S is equal to lambda. So original equation is S is equal to something fixed and you add another constant. So it is the equation of concentric circles. It's a family of concentric circles that you end up getting by different values of lambda. By different values of lambda, you keep getting concentric circles. And as far as earlier geometry that we have studied it is concerned, both these u and v's are lines at infinity. One is equal to 0, one is equal to 0. That makes it S is equal to lambda. So you put any value of lambda, you will get another circle. Put another value of lambda, you will get another circle. Okay. So if you want a concentric circle passing through x dash comma y dash, you will get corresponding value of lambda. That will be a concentric circle to given circle. And it is, I mean, just put that value back into S, and that is what is your lambda. LHS is equal to RHS. And everything falls in place. Everything that we have studied so far falls in place with this theory. If you have only one line, you have to either imagine it as a coincident line or another line at infinity. If you imagine another line at infinity, its points of intersection with given conic are imaginary. They are not real. Therefore, you end up only getting two real intersections and they are not going to be tangent at those points. However, if you consider one line and coincident another line with that, then those 2 points are going to give you tangency for the new conic sections that you are looking for. Therefore, that is what is a complete theory of intersection of two conics, which we have studied. And as a bonus, we got P square is equal to SS1 with that theory. So now suppose I want a parabola passing through points of intersection A1, A2, A3, A4. So you put your characterization of parabola on the conic section S is equal to lambda U into V, you will get a parabola. And if you get family of parabola, then you need to fix that lambda for putting additional condition. Okay, parabola itself is an additional condition, fifth condition, which will fix your lambda. And you will end up getting parabola passing through those 4. If you want ellipse passing through those 4 points, lambda will be fixed, because the fifth condition you are putting is ellipse, because the final equation should follow the characterization of ellipse, and therefore that is your fifth condition. Already 4 points are there with you, and therefore the conic will be fixed.